Yahtzee search engine. So you can search through the distributed system, and then Google, no problems with them, but then they don't have a record of everything that you've searched. I was thinking about doing Sailfish development because I used to be a Palm OS developer, but I decided against that, hence the nope. Okay, about Puppy. Puppy was created in 2003 by Barry Kay. He's an Australian. He was the chief developer and the main developer up until 2013 when he decided he wanted to step back and just work on his own little SKUs and things. Barry originally created Puppy because there was a need that he had, so he created it, and in the open source philosophy, kind of put it out there, and a community kind of formed around that. He has allowed the community to kind of do its own thing. While he does its own thing, we kind of work, and like two cars on a highway. We work together, we're going the same direction. Sometimes he skews off, sometimes we skew off, but we pretty much stay pretty concurrent most of the way. Development now that he has stepped back is done completely through the community, through our Wolf CE project, which I will touch on later. Puppy at its core is more of a design philosophy of how to build a Linux distribution. It is not what most would call a true pure Linux distribution on its own. You can build Puppy out of any other distribution that's out there. You can use Slackware, Ubuntu, Debian, Arch. We had a guy who was working on Fedora a couple years ago. I don't know if he ever finished it. Or you can build completely custom all yourself from T2. The two official versions are Slackware and Ubuntu. We work for binary compatibility. That's why we build out of other distributions so that we can leverage all the work and all the compiling that they've done. The goals is that it can easily be installed on a USB, zip disk, hard disk, any other media like that. I mentioned it last year. I actually didn't believe that you could install it and run it from a zip disk a couple of years ago. So one of the other developers challenged me and we made a bet and I lost. Puppy will run totally in RAM. We'll get into this later. There are a lot of advantages. There are some disadvantages, but there's a lot of advantages in running in RAM. And the reason we focus on that, which is the last point in this, is that we focus on older hardware. Linux or Puppy is made to boot from a CD, DVD, and you can save all that back. So you can actually have a persistent CD or a persistent DVD. There are certain people that really, really like that because they have older systems that can't boot from USB. So they can take their DVD or the CDR, put it in, boot the system, run, make any changes they want, save that back to the disk, and then the next time they boot their system, all their changes are still there. We focus on trying to make Puppy very user-friendly. In some ways, we succeed. In other ways, we don't. Some of the latest versions that have come out, we've kind of run into some problems with some of the wireless cards that are out. We focus, like every distribution, we have our problems, we have our areas we need to work on. Puppy does run extremely fast. Again, running in RAM, your RAM is faster than your hard disk. I don't care what type of hard disk you have, your RAM is faster. For applications, we have generally every application that you will need. Now, they will probably not be the ones that you are used to. The reason for that is we are focused on minimal resource usage and size. The Puppy, the latest official release, the ISO is, I believe, 150 megabytes. Compare that to something like Fedora, where you're downloading 2 gigabytes. Obviously, we can't have everything that they have, and we can't use the same versions. So we focus on finding the applications that will still accomplish the task, but are the smallest and use the least amount of resources. So some of them you may know, some of them you may not, but they're all there. Again, we want Puppy to work and just have no hassles. Like every Linux distribution, sometimes we succeed, sometimes we fail. And that Puppy will breathe a new life into old PCs. This is actually an example. I can't hook it up to the monitor to show you. Does anyone remember these, the old Toshiba Librettos? Okay, this is a 75 megahertz Pentium 1 with 32 meg RAM. This runs Puppy. I can't actually prove it right now on the slides, but if you want, come by the table later and I will boot this up and show you. If you try to run Fedora, Ubuntu, SUSE, 132 meg RAM, you won't. End of story. We focus on, like I said, the older hardware. And one of the reasons we do that is here in the US and in Europe, We are spoiled with very cheap, very powerful hardware. That is not the case everywhere in the world. In other places in the world, hardware is very expensive and there's not much of it. So the ability to take a very old system and still use that for daily tasks can be very advantageous to a lot of people in the world that don't have it as well as we do. Again, that's what Puppy can run on. That was an example. I also have a Toshiba Protege laptop. It's a 600 megahertz Pentium 3. I actually use this on a daily basis for browsing the web, checking email, and stuff like that. Again, try to run a modern full distro on a Pentium 3, and it's going to take a while. But Puppy is not limited to older hardware. As an example, my main development rig that I have is a dual hexa-core Xeon. I have 128 gig RAM in it and 36 terabytes. Obviously, Puppy runs really fast on that. When I can run it on a 75 megahertz processor, when I then jump to my workstation, it flies. That's actually the workstation right there. It outputs 6 screens. They're all 1080p. Runs fine. As far as boot times, I think my boot times are around 40 seconds. So some people really like fast boot times. They want to get their boot times down as low as possible. Personally, that doesn't matter to me because I boot my system maybe once a month. So I would rather my system run faster while I'm using it for an entire month than save 10, 15 seconds or whatever when one day a month when I'm rebooting it. That's just the INXI output because I have some people that don't believe me that this actually does run. But yeah. Okay, talking points. These are the main points that I'm going to touch on. A, running from RAM. I'll get to the stuff on the side in a second. What a layered file system is, what a squash file system is, what a save file is. Last year I touched on Wolf, which is the build system that we use for Puppy, and really that kind of deserves its own talk, but I didn't have time to make it this year, so that might happen next year. Some of the benefits for Puppy, some of the downsides, how to get involved, and information sources. Now, Puppy has various ways that it can run, and then you can install it. When I talk about running from RAM and the layered file system, I'm specifically focusing on what we call a frugal install. You can install Puppy like a regular distribution where everything is on a flat, level, single layer file system, just like if you installed Ubuntu, Fedora, SUSE, whatever. That takes back, though, on the benefits that we're going to go over. Because Puppy has different ways that you can install it and run it, we have what we call pup modes, which when the init script runs, what pup mode determines what capabilities your system will have. Personally, I always run in 12, which is the frugal. I have my system, it boots off of a hard disk, but it runs entirely in RAM. Okay, why do we want to run in RAM? As the saying goes, because disk I/O is dumb. In most computers, your disk I/O is one of the, in modern computers, your disk I/O is going to be your slowest point. Now, if you have an SSD, then this isn't going to be as bad. But again, we focus on older hardware. If you're using an old parallel ATA drive in your system, your device I/O is very, very low. And if you're constantly having to read from the disk, you're going to suffer because you have to wait for that information, that data to be pulled out. Did I get these out of order? No. Okay. So, layered file system. Layered files, we use AOFS, which is another union file system, or the advanced multi-layer unification file system, which was designed because the developer, and I cannot say his name right, so I'm not going to butcher it. How many people here have ever or have heard of or used the standard union file system? Anybody? Okay. AOFS was designed because he wanted some extra features that weren't involved, that weren't actually included. So he forked it, created AOFS. A lot of those features have been worked back in to the mainline UnionFS. Some kind of refer to AOFS as kind of like the advanced testing because he'll implement a feature, it'll get worked on for a while, it'll get tested, and then UnionFS will later pull it in. There has been some talk about it getting actually merged into the mainline kernel. As of yet, that hasn't happened, and I kind of don't think that it will. As for the reasons, well, there are a lot of conspiracies out there. I don't know. They're probably all not true, but no reason to get into that. So how does a AUFS or a layered file system work? Does anyone remember these in school? Okay, some people do. A wonderful overhead projector. This is the easiest way for me to explain how a layered file system works. Is your teacher would wheel one of these up to the front of the class, and they would put a sheet on it, and it would have information, and then they could write on it, and that information would then be shown up on the screen. And then they could take another sheet and stick that right over top of it, and it could have more information on it, and then that would be displayed right up on the screen. This is how the layered file system works. It's just like a stack of transparency sheets, except those transparency sheets have files in them. And as you layer in files, individually they're separate. But in the user space file system that you see like what's on the wall. You see all your files in your standard directory. This is an example of the layered system in one of the releases, the Lighthouse PUP. It's a 64-bit release. We're going to start we'll start at the core system, which is the red one. The core system is your main system, all your main files. That loads. You can do, which we will touch on, what's called additional things or squash file systems, which are extra layers, and you can load those in. Now with Lighthouse, those are actually layered in underneath your core system. That way, if you have a lib conflict, your system is going to run. The way the layered file system works is whatever file is on top takes priority. So if you have two of the same file, the one that's in the top of the higher layer is the one that the file space and that you're going to be able to see. The other file is still there, but you're not actually accessing or using that. So if you have two versions of glibc, whatever one sits in the top is what the system is going to try to use. So with Lighthouse, all the additional packages that were made to actually sit below that main layer. So if there was some library problem, your system would still run, you just wouldn't be able to use that application or that bundle that you loaded. On top of the core system would be your personal information that you save. It's important to understand that all of these layers from a core system down into the optional SFS, all of these are read-only. So if you go to make a change in the file system, that gets saved in the top layer, this temporary storage. Now that sits, as I said, in RAM in its own section. Well, obviously, if you're making changes, you want to save those changes for tomorrow. So when you shut down, there's a script that runs that we called snap merge, which takes everything in that top RAM layer and saves it into a single file that then is saved to your hard disk. You can save it to a USB, you can save it to a CD, you can save it wherever you like. When you boot the next day, your core system loads, and then it finds that persistent storage file, your save file, and it layers it right over top. So then all your changes that you did previously are all still there and you can access. And then a new temporary storage layer is created on top of that for any new changes that you want to make. And then again, when you shut down or when you choose while you're running your system to save it, the snap merge script will take an existing persistent storage file, everything that's in your RAM layer, will compare those and then save out all the new changes. So then the next day, your persistent file has all the changes that you did from the day before. This is an example of how everything gets layered in, where everything gets layered in. We have a directory, it's the init.rd, that stays and exists the entire time while you're using your system. This is where all of the separate layers are mounted. If you look down to devloop 1, that is our read-write layer. That's the layer in RAM that we can copy to and edit files in. Everything else below that is read-only, and they're the separate layers of the file system that are running. With Lighthouse, you can load up to 40 separate layers. Different releases have different numbers. Some of the developers will limit it to 10. Some of the developers will limit it to 4. The reason for this is there is a slight performance hit when you're loading massive layers, because when you go to look for a file, because you have all those layers, each one of those layers has to be searched individually for whatever file you're looking for. So if you just load up on layers, there's a lot of extra searches that you're going to be doing in the background when you're looking for something. So some of the developers will limit it to a certain number. With Lighthouse, the lead developer's attitude is you can load as many as you want, just have at it. Okay, this is just a Rox view file manager of the actual init.rd where all the separate layers are saved. Okay, this is a picture of just one of the layers, the PUP RO14, which is my QMMP media player. By the way, does anybody use QMMP? No? Okay, most people don't. In the individual layer, okay, as we said with the slide sheets on the transparency projector, if you were to pull just one of them out and look at just that single layer, this is an example of what you can see. There's the root, and then you have Etsy folder, user folder, and the var folder. And inside that is all the files specifically to that package or that bundle. In this case, it's QMMP. So in that layer, these are the only files that exist. We don't have the rest of the file system within this layer. It's self-contained. Here's an example of within the user bin of that separate layer, we can see here's all the binaries for QMMP that it's going to use. And I have the tree broken out on the side to where you can see everything that is needed for that application is going to be bundled in that squash file system. Now, this is not a container in the way that most people consider containers. All this is just a way to keep everything in a box, so to speak, together. This does not provide any security between one binary and another. It's just simply a way to package one thing completely together and being able to work with it as a single file instead of a mass of files. The difference between a squash file system, which I will talk on later, and a regular install package is the squash file system, because it's a layer, you can load and unload it whenever you want. So if I'm using my computer one day and I decide I don't want to use QMMP at all, I can actually completely unload it out of the file system and it doesn't exist. It's not like uninstalling a package. Well, it is. But I'm not uninstalling a package because all I have to do if I want to reload it is just click on it, reload the layer, and it's back in the file system. If you worked on your Linux computer and you decided every day that you wanted to install and uninstall stuff, you're going to waste a lot of time. And eventually, you're probably going to break something. With the layer, it's read-only, which is why you can see when I go try to create something new, I can't. There is a way to write and create SFS packages. We actually use a script that we wrote called Edit SFS. We're really good with names, so we just try to keep it simple. And that will allow you to create layers manually by yourself. But once that layer is created and you're using it, you can't edit that layer. Anything I change, for instance, if I wanted to go in and drop in, let's say there was a plugin for QMMP that I wanted to add, I can't just drop it into this directory. It's a read-only layer. I can add it to my file system and then it gets saved in that very top layer and then gets put into my save file so it's there on all my next reboots. But this layer itself, this SFS, is read-only unless I break the entire thing apart and then go through the process of completely rebuilding it. So I've been talking about a squash file system. Let me actually explain what it is. It is a compressed read-only file system for Linux. I'll just let you read that instead of reading it out loud to you. Okay. This is actually the script that I was using. This is the output when I was creating the QMMP SFS package. The SFS packages are not encrypted. They are, however, compressed. And in this case, you can see that we compressed down from 69 meg down to 14. Now, when you load these, they are uncompressed into memory. So when it sits on your hard drive, it's that compressed single SFS file. When you load it into your file system, the system will open it up, expand it, and then load it into RAM as an expanded file. It does not load in RAM compressed. Now, with AUFS and SFS, like I said, we can load and unload these layers at will. An example of how I personally use this is there'll be times when a friend of mine or something will need something that I have on my system. Instead of me uploading it to a site and then giving them a link, I can simply load up my LEMP stack, start the service, have him connect to it, get whatever he needs, stop it, and then remove that out. And it's no longer in my file system. So if someone were to get into my system, they're not going to be able to go, okay, he's got a service there or a LEMP stack, let me start that up and run it, because it's not existent in the user space file system because it's been unloaded. Yes. Right now, okay, the question was, what do you do when you want to unload a layer and there's a process that's being used inside that layer? Right now, the way that we have it set up is if you try to unload a layer that has, so QMMP, we'll use that as the example. If I'm running QMMP and I decide, okay, I want to unload that and I have it running, you get a little dialog box that'll pop up that's like, this process is being used, you're trying to unload it, what do you want to do? And your options are kill the process and unload the layer, or stop and then go stop the process. We don't really have any fancy solution for it. It's just do what you want. Yeah, it's simple. It's to the point. Some people have wanted to create, a timeout system where it waits a certain amount of time and then unloads. And personally, for me, I think just putting up a dialog box in front of the user saying, you're trying to kill something that's running. If you want to, go ahead. But if you don't want to, go fix whatever you're doing. Stop the process and then unload. Did that answer your question? Okay, cool. Mm-hmm. One of the things with Puppy, and sometimes people like it and sometimes don't, is a lot of older versions of Puppy were based on Slackware. So we have a lot of the attitudes of Slackware, whereas if you want something done, you should have the choice to do it. The system is, other than how the system runs with the layer file system, it's not going to make choices for you. It's going to let you make those choices. For a standard user, they're not going to get into loading layers, unloading layers. They're just going to boot their system up and run it. If you want to dig in, it's not going to make choices for you. It's going to require you to actually make those decisions. As I said, the SFS files are read-only. So any changes that you do are going to be saved in that top layer. And this is the top layer, actually. pup.rw is where all your changes are saved. So you start your system up, fresh system, the core system loads, the core SFS loads, and then I have my temp file storage. Now in this case, I installed my NVIDIA driver. So it was saved in that top layer, which is the init.rd pup.rw directory. And as you can see, under that is your normal file structure, folder structure that you would see. And in the bin folder is all the things that I have installed since starting the system up, which is GFTP, NVIDIA, and tree. There are no other binaries here. All the other binaries that are on the system are in that lower layer. So in this layer, we're just looking at that very top RAM layer. Now, down here in the corner, well, in the middle over on the right-hand side, you'll see a .wh file. This is what is called a whiteout file. Now, as I said before, if you have multiple files or a single file in multiple layers, whatever layer or whatever file is on the top layer is the one that the system will use. The question comes up is, okay, what if I have a file in a lower layer and I want to delete it? Since that lower layer is read-only, how do we get rid of that file in what our user space that we're using? The answer to that is what's called a whiteout file. Again, we're great with names. Anybody know how whiteout works on a paper? It doesn't erase what's on the paper. It simply covers it up so you can't see it anymore. And that's what the whiteout file does. When AUFS is working, it sees this file, a whiteout file, and it goes, okay, there's a file of this name in the lower layer, but I'm going to block it so it can't be used, can't be seen. If you then go back and delete that whiteout file, the system will instantly revert and allow you access to the file back in the lower layer. Yes. Okay, the question was, does that mean you're always consuming disk space? Yes and no. I wish it was a straightforward answer. You will your save file will increase in size, yes. Now again, because we're talking about a more minimal system, the rate that you're going to increase is very slow. Now, if you just load a ton of stuff, then obviously you can fill it up. You can expand the save file out as much as you want. Right now, I think my save file is, I think it's just under 2 gigabytes. and that's a save file I've been using for over a year. It also does take some thought as far as what you want to put in your persistent storage, because I have USB drives. So music, photos, there's no reason for me to save that in my personal save file when I can just save it on an external hard drive. So you kind of get into the mindset of what do I need to be in my save layer, in my save file, and what can just be on removable media that I'm going to access every once in a while. Your save file we primarily focus on it being used for configuration and applications that you've installed. It is an SFS file, and it can be encrypted. There are two options. One is AES, and the other is please don't use it. It basically, you just put in a password, and it does an exact straight XOR, and then it actually saves the password in the super block of the file, which is the worst thing ever. I don't know why that was chosen. But that is going to be depreciated, so it's just going to be AES is your option. You can save your save file to any device. So if you boot off of a CD and you run your system and you want to shut down, you can save that save file to your hard disk. If you have a Windows machine and you've booted Puppy off the CD, you can save that save file back to the Windows hard drive. It's just a single file that you choose where on the hard drive you want it to be. You can save that to a USB stick. You can save it to an SD card. Any external media that you have that's writable, you can save it to. And then the next time Puppy boots, it will look at all the media that's attached and look for save files and then say, okay, I found these 3 save files. Which one do you want to use? One of the things that myself and some of the other people that heavily use Puppy is we just simply create backups of our save file, and I'll get into this later. So, well, I'll just save that for later. I won't spoil the fun. Save files, by default, are written at shutdown. Now, because you're running in RAM, this is one of the possible downsides, is if you have power loss, anything that you've done isn't going to be saved. You can choose to save your save file at intervals. For a while there, I think the default on a Frugal install was every hour. It would automatically resave any changes in that RAM layer. Some people set it for less than that. Some people set it for never and only at shutdown. That's up to the user as far as what interval you want that to be at or if you want that to happen at all. The other thing to keep in mind, though, is, again, when you're talking about older hardware, you're talking about slower media. So while you're in the process of saving back your changes to hard disk, that is going to be a point where your system is going to run slower. Okay. Benefits. As you can see, my wonderful edits from my slide last year. As I said, I don't care what media you're using, what type of drive you're using, your RAM is faster. Bandwidths for DDR2 and DDR3 compared to the appropriate hard disks of those generations, you just can't compare. Even the highest speed SSD. Now with the new NVMEs, I haven't really looked into them, but I still don't think they're as fast as RAM. I don't believe so. I don't think that many people that are focusing on Puppy are going to go out and buy a whole bunch of NVMe drives, though. Flexible install options. As I said, you can install it to pretty much anything. USB, optical media, hard disks, SSD, SD cards, compact flash, zip disk, whatever. We actually had a while legacy in the code where you could actually save it back to a floppy disk, which I don't know why it was still in, but about 1.5 years ago, one of the developers was going through and was like, hey guys, can we take this out? Because nobody's going to do that now. Simple backups. Like I said, all your changes are saved in a single file. So if you want to back up your system, you make a backup of one file. You can drag and drop it. You can create a cron job. I have a cron job that runs every day, and it simply takes my save file and saves it to an external drive and appends the date to it. So that if I completely nuke my system, I mess something up and I can't recover it, all I have to do is drop to shell and copy that file from my external media back to my main drive, restart, and there you go. All your files and everything are back. There are various solutions for backing up your Linux distro. None of them are quite this easy. It is literally as simple as a drag and drop. If anyone can come up with a simpler way, please let me know. Compromise and corruption protection. Because all of the changes are saved in that single file, and all changes are within that RAM layer, your main core files don't get changed. So if somebody gets into my system and starts messing around with files, I can simply go into that the pup RW directory that I showed you, or look in my save file. And if I go in and I say, well, this is weird, I've got my LD-SO conf file in my Etsy folder is in my save file. Well, I haven't changed that. So what's happened? I can go in and I can look and see what has changed and then choose from there. And again, because the original file is still in a lower layer, if a file is compromised, you simply delete it and your system reverts back to the older uncompromised version. Now that does require the user actually checking. We can't make it flawless, so you're going to have to actually go in and look to see if there are changes, if that's something you care about. I would hope that it is, but if it's not, that's on you. You can also run Puppy with absolutely no persistence, and that is entirely in RAM. And it will not save. So when you boot up, there's just simply an extra flag that you choose at boot up, which any change you make is, of course, in that save layer. But when you go to shut down, it will not ask you if you want to save it, because you've already made the decision. When I power down, every change I want blown out completely. A lot of the Puppy developers that I've talked to set up their systems in this way, in that we will custom build our system with the applications and the configuration and everything that we want. We'll remake that core SFS file, and then we'll just run without persistence. Because we know how, if we need to change or tweak something, we can go and edit our core system SFS file. So that way, we don't have to worry about saving. We don't have to worry about the performance expense. Because like on this little machine, when it actually does go to save the files down, it actually slows the whole system down. Again, we're talking about 75 megahertz on this. If anybody remembers using systems from that era, it was pretty much one thing at a time. So on an older system like this, I won't have a save file because I don't want the hassle. I don't want to have to wait. I don't want the performance hit, because there's not much performance there to be spent. The other benefits, I put this up kind of as a joke, is bragging rights. In the Linux community, we kind of always like talking about doing something a little different, or having something set up a fun, interesting way from everybody else. And Puppy does a lot of things different. Okay, already did that. Downsides. I'll just skip right to the slide. Puppy runs as a root. Now, this is changing. In a lot of the most recent releases, all of your user space applications will run as a non-privileged user. Historically, the reason that Puppy ran as root is because it wasn't focused on the hardcore user. It was focused on, my grandmother wants to get online, wants to watch cat videos on YouTube, wants to send emails. I don't want her running Windows. I want her on a system that I can easily maintain, easily edit, and I want her to run Linux. So I can simply take Puppy, install it, and run it. Would she be better off running as a non-privileged user? Yes. But she's been running XP, which she's running as administrator anyway, so there's no real change. Like I said, nowadays, all your user space applications, all your internet touching applications are going to run as a non-privileged user. So we're working on this. It's getting there. Package management. Puppy really doesn't have a package management solution. We have our own package installer called a .pet file. As I said, great with names, which is basically just a tar.gz or a tar.xz file. We haven't really put much effort into package management because, as I said in the beginning, we build our distribution out of another distribution's binaries. So if you go and you get a Slackware-based Puppy, you can simply use the Slackware package management system. You can use gslap, you can use slapget, that's all possible. And you can grab from actual Slackware repositories for packages that we don't have our native .pet package for. Because of that, we haven't really put much effort into making native packages. The one downside with that is that, for instance, if you use the latest Ubuntu-based Puppy, and you go start downloading extra packages that you want for different applications, you're going to be pulling a lot of extra stuff along with those files. When we build a package, try to strip it down to the most minimal. In some cases, we will compile them without certain options to try to keep the size of the actual package down. Again, we're going for minimal as possible. So if you're going and you're grabbing different applications from Debian or Ubuntu to install in your puppy, you're going to very quickly bloat the size. The other problem that you will have is because we strip as much out as you're not needing, if you want to go download something from, again, let's say an Ubuntu repository, you're probably going to also have to find the dependencies because we're not going to include the libs because we are only including the libraries that you need for your system to run with what we've installed. So unfortunately, you are probably going to have to track down some libraries, which leads into the next one, which is there isn't really any online central location for all information. And when we get to the last slide, you'll see this. Puppy stuff is scattered all over the internet. I made a comment last year, and I caught flack from a couple of the other devs. We actually had official packages that were hosted on RapidShare. That is a horrible situation. I've been trying to work towards a solution. But Puppy, a lot of the developers do it for fun. We don't see it as a job. We don't see it as something, you know, that we want to spend 5 hours a night on. Working on Puppy is a hobby. So we work on it when we have time. We work on it when we want something fun to do. So because of that, there isn't as much of a drive for let's completely rebuild something from the ground up. Because for the longest time, all we've done is just tweak. Again, we are not professional coders. The coding style is very, very messy. If you actually go through and look at some of the shell scripts, you will probably be horrified at the lack of standards. Sometimes personal notes get added in. I made a comment last year, and again, I got flack from one of the other devs where one of the older versions, someone actually left a shopping list in the comments of the shell script because they were working on it, and their girlfriend, their wife said, hey, remember that you need to get A, B, and C at the store. So they're just sitting there, so they just make the note to themselves. And I hope they got the stuff. And then they completely forgot that they had that in there, and then that script ends up getting shipped. So if anybody actually stopped and looked through, they'd be like, oh, look, he needs to get bread. Thankfully, there's guys that are going through and now checking, and anytime they see that, they're deleting it out. The other thing is, again, we're doing this as a hobby. So we don't really focus on it being super, super pretty. And a lot of people say that Puppy is ugly. And I have some examples of that coming up. The other thing that a lot of people nowadays see as a downside is the fact that we still use sysvinit. We do not use systemd. In general, the Puppy community is very anti-systemd. I'm kind of the lone wolf in that I'm trying to work systemd in. Why would I do such a thing? Because systemd has advantages in some ways. So, yeah, we will not be if I can manage to do it. You know, it's not going to be the full implementation of systemd that you're going to get on Fedora or any other distribution. It's going to be as cut down as possible to do as little as possible for helping speed up the loading and unloading. And I know it is possible, because there are products from the company Devon IT that they actually use a layered file system and use systemd and have seen massive improvements in their boot up time and their shutdown times. So it is possible. It's just I have to figure out how to do it because I'm not a professional. Okay, I did that. Okay, this is one of the older puppies. As you can see, it's not very pretty. The older versions didn't really focus on looks, and the newer versions haven't really focused on looks either. There are a couple guys in the official forums that have kind of taken up the burden of trying to make Puppy look less like it's 1995. The question was, if we have a web converger or something for doing a kiosk for just web browsing. There was someone in our community who was making a specific puppy system for kiosks. I don't know whatever happened to him. He just kind of disappeared off the planet. Again, puppy is designed, it's a lot of people that are working on it as amateurs. So people come and go and do what they want. But that's one of the first versions. This is one of the later versions. It doesn't look bad. The icon set, some people say, is a little cartoony, but you can see a massive improvement between what it used to look like and what it looks like now. And that's actually one of my systems. I just went kind of crazy with bars and stuff. Okay, here is where you can go to get involved. As I said, everything is everywhere. There's the official site, then there's the official community site, then there's the main developers blog, then we have the official forum, then we have a backup forum. And it's just kind of all scattered all over the place. I'm hoping that in the future we can get everything back down and kind of centralize everything. We have had some people who have wanted to get involved in the community and have been really, really excited to do the stuff, but then they kind of hit the brick wall of, well, where can I go to learn more? Where is the information that I want to find? So like I said, every distribution has its problems. We definitely have ours. But all I can say is that, like every distribution, we're working on making things better. My personal site is right there. It's q5sys.sh. My email, the reason the star is there is because you can put anything in front of that at, and I will get it. If you have any questions, feel free to send me an email. I'll be at the table, so grab me. That's it. Thank you. Does anybody have any questions that I haven't touched on that are burning in your mind? We have one back here. Okay, the question was, have we thought about moving to OverlayFS? And let me phrase this as far as I have thought about moving to OverlayFS. No one else has. The attitude is, well, AOFS works great, so why do we need to change anything? Well, again, with everything, there are positives and negatives. I don't know a great deal about OverlayFS. Someone actually asked me that last year. So I have been looking into it. But just, again, this is something I do in my spare time as a hobby. So, but if you would like to hire me and pay me hourly to implement OverlayFS, I would be happy to do that. Yeah, if people are interested in the contrast and comparison of different layered file systems, the dev and IT guys, they're the ones to talk to because they've done a lot of testing in this. Any other questions? Yes. Mm-hmm. Mm-hmm. Okay, the question was, with using a persistent USB, is taking that between different systems. On this system right here, this USB drive, this actually goes between a bunch of different systems of mine. I plug it into whatever system I want, and I boot up. Now, the main problem you're going to have with doing that is your graphics drivers, because if you go from a system with NVIDIA to a system with ATI or AMD, your Xorg, obviously your Xorg comp file is going to be written to be using the NVIDIA script, the NVIDIA driver. So when you go to an AMD ATI machine, well, it's going to try to load the NVIDIA driver because that's what it has in its comp file. Some people avoid that by just making copies of the different save files so they have multiple copies. The downside with that is then you have to manually on your own sync them back together. The other solution is, when you take that USB stick to another computer and you start it up, is there's a flag that you would start at the beginning, which would just be no X. And that will boot. And then at that point, you run Xorg Wizard and then choose what graphics driver you want to use and then do it that way. But yeah, you can take the USB to any computer that you want and do whatever. You could do separate save files, but different configurations within that. We don't have anything like stock that would do that. That wouldn't be too difficult because it would just be something that you would add at the end of the init script before it would actually load X to choose what and you just swap your config files around. So, any other questions? Alrighty. Well, thank you very much.
Citrix Zen Server gives you everything you need to integrate, manage, and automate a virtual data center, all on an enterprise-class, cloud-proven virtual platform, and at a third of the cost of other solutions. But why even bother with virtualizing your server infrastructure in the first place? Well, let's say you have a traditional one server to one application architecture, but you're running out of resources and performance is suffering. Once you order new server hardware, you'll wait for delivery. Configure it, install your business application, stage and test the server, and finally, add it to your production farm. If you've been through this process before, you know it can take weeks or even months. You also know it's a manually intensive process that will burden your team every time you outgrow your current setup. With a virtual server solution, you could accomplish all of that in less than half a day. Server virtualization software separates the OS and application from the underlying server hardware. And with multiple virtual machines on a single server, you can use each of them to run different OSs and applications. This makes it possible to move your virtual machines from one piece of hardware to another whenever you want, to maximize utilization, simplify maintenance, or recover from a hardware failure, and without slowing down your applications or users. Clearly, server virtualization provides big benefits, and Citrix Zen Server provides even more. Since it's built on an open platform, Zen Server plays well with your existing hardware, storage systems, and IT management software, as well as with the industry's leading cloud service providers. Best of all, you can get started by downloading a fully functional, production-ready version of Zen Server for free. After a 10-minute installation process, you'll see how easy it is to start virtualizing your workloads and automating your IT management processes. And when you're ready for a richer set of management tools, just upgrade to one of the premium editions of Zen Server. So whether you're interested in virtualizing servers for the first time, expanding your server virtualization footprint, or moving server workloads to the cloud, download and install Zen Server today and see how it can help you simplify your IT environment. Citrix Zen Server. Do more. Don't spend more.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.